Alright, so before we start, actually we doing some work and also research for this slide and information. So let's see for the first info, which is the question is the heat treatment process involved. Heat treatment is a process of heating and cooling metals or alloy in a controlled manner to alter their physical and mechanical properties. The heat treatment also process involves several steps, which is we have three steps, and the first one is heating, and the second one is soaking, and the third one is cooling. Alright, so we start from the heating first, and the metal or alloy is a heat to specific temperature, and the temperature depends on the composition of the metal and the desired properties. And the second one, soaking, which is the metal is held at the specific temperature for a specific amount of time. This allows the temperature to evenly distribute through the metal. And the last point is cooling, which is the metal is then cooled down in a specific manner. The cooling rate can have a significant impact on the final properties of the metal. So we move to the second slide. Okay, so for the second slide, we explain about the heat treatment process involved also, and these are several types of heat treatment process, including we have four. The first one is annealing, and the second one is quenching, and the third one is tempering, and the fourth one is normalizing. Alright, so we want explaining about the annealing first, which is this process involves heating the metal to a specific temperature and then slowly cooling it down. This process is used to reduce the hardness of the metal and increase its ductility. And the second one is quenching. This process involves rapidly cooling the metal in water or oil, and this results in a hard, brittle metal that is useful for making tools and other applications that require hardness. And the third one is tempering, which is this process involves heating the metal to a specific temperature and then slowly cooling it down. This process is used to reduce the hardness of the metal while maintaining its strength. And the fourth one and the last one is normalizing, which is this process involves heating the metal to a specific temperature and then cooling it in air. This process is used to increase the strength and toughness of the metal. And we move to the slide number 5, which is I'm choose annealing in annealing process, and I will explain first and then I will give a point. And annealing is a process that involves heating a material and then slowly cooling it down to alter its physical and or chemical properties. The equipment, temperature, and time also parameters of annealing can vary depending on the type of material being annealed and the desired outcome. Here are some general guidelines. Alright, the first one I will explain about equipment, which is the equipment used for annealing can vary depending on the type of material being annealed. For example, annealing of metals can be done in a furnace, while annealing of a plastic may require an oven or a hot plate. And the second one is a temperature, which is the temperature used for annealing can also vary depending on the material being annealed. In general, the temperature used for annealing is below the melting point of the material. For example, annealing of steel is the typical done at a temperature between 600 to 900 Celsius, while annealing of glass is done at temperatures between 400 to 600 Celsius. And then and the third one is a time, which is the time required for annealing can vary depending on the material being annealed and the desired outcome. In general, the longer the annealing time, the more significant the change to the material. For example, annealing of steel can take anywhere from a few hours to several days depending on the desired outcome. So, it's important to note that the equipment, temperature, and also time parameter of annealing are highly dependent on the specific material being annealed and the desired outcome. So, and the next slide is, alright, so I will explain about the desired outcome of the heat treatment process. Okay, the main desired outcome of the annealing process are, the first one is a softening of the material, which is annealing is a heat treatment process that is used to soften a material by reducing its hardness and increasing its ductility. This makes the material easier to work and it can be formed, shaped, or machined more easily. And alright, so for this point, reduction of internal stress, annealing can also reduce the internal stress within a material, which may have been caused by previous manufacturing process. This can help to prevent distortion or cracking of the material during subsequent processing or use. Alright. And then the main desired outcome of the annealing process are improved machinability by softening the material and reducing internal stress. Annealing can improve the machinability of the material, making it easier to cut, drill, or machine. And the second one is increased uniformity. Annealing can also help to increase the uniformity of a material's structure and properties. This is particularly important for materials that have been subject to processing, which may cause variation in the material properties. Alright, and then the second last one, which is the question is, what are the advantages of this particular heat treatment process over other methods? And it would be helpful to know which specific heat treatment process you are referring to, as there are many different methods of annealing, each with their own advantage and disadvantage. And the first one, improve ductility. Annealing can increase the ductility of a material, making it easier to bend, form, and shape without a cracking or breaking. And the second one, reduce hardness. Annealing can reduce the hardness of a material, making it easier to machine and work with. And the third one, reduce distortion, which is annealing can help prevent distortion in a material by reducing the thermal gradient that can occur during cooling. So that's all for my presentation. So thank you.